Welcome back, Patriots. Let's go ahead and take care of your Unit 7 review. Now, we're going to go through this, and unless it says otherwise, I don't care which method you use. So, like, for example, on these first sets of word problems, none of them tell you which method you've got to use, so you can use whichever one you want. However, we get farther down, and on problems like, where'd it go? Here, like number 20 says to use substitution. So the purpose behind those is I want to make sure that you're learning and remembering how to do all the different methods that we covered this entire unit. So, but if when in doubt, use whatever you want to, and I'm most likely going to use matrices quite a bit because they're the easiest ones to do. All right, let's go ahead and jump into this. Now remember, we're looking at the question to see what the variables are going to be, how many of each type of ticket. So it looks like I've got two different types of tickets. And I'm going to look back up here and it says we got floor seats and balcony seats. So I've got F for floor seats and B for balcony seats. All right, so the theater sold 900 tickets. Now, that 900 tickets, that is a total. And since I've only got floor and balcony tickets, what that means is if I add up the number of floor seats plus the number of balcony seats, I get 900 seats total. Okay, now on my second sentence, I've got floor seats cost $12 each. Well, that $12 each, that's going to be a rate. Balcony seats were $10 each, and that is also going to be a rate. And then I keep on going. Total receipts were $9,780. So if I go through and make an equation out of that, I'm going to have 12 times the number of floor seats plus 10 times the number of balcony seats equals 9,780. Now, something to point out on these is that this will happen quite a bit, these two styles of equations. This one right here has to do with the number of seats. This one down here has to do with money. You're going to get that quite a bit where instead of, the problem might be different. Instead of number of seats, it might be number of animals. It might be number of coins. But on that number of, you're going to have first variable plus second variable equals the total. Then you've got the one down here that I labeled as money, or another way of looking at that is the value of them. In that case, you're going to figure out how much each item costs, how much each item is worth, and then multiply the worth, the 12, times the number of them, the F. The worth, 10, times the number of them, B, equals the total value, which is 9,780. So you're going to get this style a lot. Now, since they are both in standard form, I'm going to choose to do this one using a matrix because it's easy to type in the matrix and easy to solve. So let's turn my calculator on. We're going to go to second matrix, arrow over to edit. And now this is going to be a 2 by 3 matrix, so 2 enter, 3 enter. And now I'm going to have to create my matrix, which I'm going to do right here. That is 1, 1, 900, 12, 10, and 97, 80. So I press 1, enter, 900, enter, 12, enter, 10, enter, 9,780, enter. Now important, make sure you quit out second mode, second quit. And then go back to the matrix menu, over to math, all the way up to REF, matrix, and then enter on matrix A. And now it gives me 390 and 510. Now keep in mind that my floor was over here on the left-hand column. So I had 12 and 1, 1 and 12 over there. So whenever I'm reading this matrix at the top, I see 1, 0, 390 that says 1 floor plus 0 balcony is 390. So that tells me that my floor tickets, I sold 390. My balcony tickets, I sold 510. Make sure you're keeping track of which variable is in which column and being consistent with it. Okay, number 2, an ice cream shop offers 8 pints of chocolate ice cream. Oh, I'm going to jump to the question. Find the price of each pint of chocolate and vanilla ice cream. Well, that's easy. It gives me C for chocolate ice cream and V for vanilla ice cream. Okay. An ice cream shop offers 8 pints of chocolate and 6 pints of vanilla for $22. Well, when I've got 8 pints of chocolate and 6 pints of vanilla, that's going to be rates on both of those, and then a total of $22. So I make that equation. I'm going to have 8C plus 6V equals 22. Now, 4 pints of chocolate, again, that's going to be a rate, 4 pints of chocolate, and then 8 pints of vanilla, another rate, sells for $22 as well. So let's go ahead and write that one in. 4 pints of chocolate, so 4C plus 8V also equals 22. Now, this one ends up being a slightly different setup. Earlier where you have the number of and the value of. Other times you'll end up getting things like where you have 2 different value equations, and that's what this one is. We've got 2 different value equations. Let's see. We saw that the other day with the Sally and Lucy example on their trying to save up for the iPhones. It's going to take them 23 years to buy an iPhone on. Okay, let's go ahead and turn this into a matrix because it's in standard form as well. So then I'm going to get 8, 6, 22. 4, 8, 22, remembering that chocolate is in the first column and vanilla is in the second column. Going back to the matrix menu, over to edit. I'm going to press enter on the dimensions because they're already in there, and then I'm just going to press overwrite them. So 8, enter, 6, enter, 22, enter, 4, enter, 8, enter, 22, enter. Back out. And then remember, I can always press second enter to get the last thing I typed in, save me some time. And so the price of each looks like chocolate, which is in my first column, is $1.10, and then vanilla is $2.20. Keeping in mind that you've got to convert that into dollars and cents, which is why we're putting that extra 0 on there, because we need the pennies. Number 3, I'm going to jump down to the end. Which system of equations can be used to determine how many multiple choice questions M and how many true-false questions T? Well, that's easy. It defines them for me. So I've got M for multiple choice and T for true-false questions. All right. A history test has 30 questions worth a total of 250 points. Now, those two are both of my totals. And then either question is either multiple choice or true false. Okay, that's good because it means that there are no other types of questions. There are no essay questions or anything like that. So I can actually use that to come up with my first equation. Because if I take all my multiple choice questions plus my true false questions, that's going to give me 30. That's sort of like on number 1 where I said the number of points. Question number 2 is going to be the value, okay, the value of those questions. So if I read through here, I can see that multiple choice questions are worth 10 points and true false questions are worth 5 points. Those are my 2 values. So I did M first, so I've got wrong marker. I've got 10M plus, over here, true false are worth 5, so 5T equals the total value, which is 250. Now, once again, all in standard form, I'm going to choose my matrix. So 1, 1, 30, 10, 5, 250. Go back to the matrix menu, over to edit, press enter to get past the dimensions. Now across the top, 1, enter, 30, enter, 10, enter, 5, enter, 250, enter. Now I'm going to go and quit out, pull up my RREF again. And now, again, first column is M, so multiple choice, there are 20 of those, and true false, there are 10. All right, number 4, we're going to move on. Look at the questions. How many flowers does each girl have? Well, that means that we're going to be looking for the number of flowers for the girls have. So the girls here are Jessie and Susie. So I've got S is Susie's flowers, and J will be Jesse's flowers. Okay, let's see. Susie and Jesse work at the flower shop. They are making arrangements for an upcoming holiday for Valentine's Day. Susie has 3 times as many flowers as Jesse. Okay, so this is one that students can kind of get confused with. The question is it S equals 3J, or J, actually write a J there, equals 3S. Well, it really boils down to who has more flowers. Okay, in this, when I read it, Susie has 3 times as many flowers as Jesse. Susie has more flowers because she's got 3 times as many. So let's just plug in here. Let's just pretend that Jesse had 5. That would mean that Susie had 15. Over here, if Susie had 5, then Jesse had 15. Which one of those is going to fit the situation? Well, Susie's got more flowers. That's going to be the top one. So we're going to go ahead and write that into equation number 1. S equals 3J. Now, together they have 136 flowers. Well, again, that's that whole count thing. So we got S plus J equals 136. Now, this is our first one that is not matrices. I'm going to erase this out so that I can have room to write here. On this one, however, I've got one of them that has variable equals. I've got one variable that is isolated, which means that is a perfect substitution problem. So what I'm going to do is I am going to take this S, well, the 3J actually, and substitute it in here for S. So I'm going to have S, I'm going to replace the S with parentheses plus J equals 136. Now inside the parentheses where the S was, I'm going to put a 3J, and now I'm going to solve. There's no distribution to do, and so 3J plus J is just 4J equals 136. Now we're going to divide both sides by 4, and so 136 divided by 4 is 34. Now Jesse gets 34 flowers, and then Susie, I'm going to go back to this equation. Actually, I'm going to come down here. S is equal to 3 times J, which is 34, and so 3 times 34 tells me that Susie has 102 flowers. Number 5, Jesse made 5 less points than twice what Alice made in her tests. Their scores are labeled 190, or scores totaled 191 points. So what was John's score? Now it's nice it gives us our variables here, John's score and Alice's score. So we're going to have two equations. The first one is this total, where they total 191 points. That's going to be where we have, add them together, J plus A equals 191, or A plus J. Now if we'll notice, that doesn't help us much because all of these have that exact same equation. So it's really going to hinge on this top sentence here. John made 5 less points than twice what Alice made on her test. So let's go through here. John equals 5 less points. Now, this whole less than is one of our switch order phrases. It gives us the idea of subtraction, but we're subtracting 5 off the back end. Then twice what Alice made. Well, if Alice made A, and twice that would be 2A, so we're looking for J equals 2A minus 5. J equals 2A minus 5 is option C. Okay, number 6. Arcadia has a total of 36 in her coins in her piggy bank. All the coins are either dimes or quarters, and they total 420. All right, so again, we've got D and Q because we've got those there. And our total of 36 coins means we've got D plus Q equals 36. Now, I look at this one over here. D plus Q equals 420. Okay, D is number of dimes, Q is number of quarters. Is it true that the number of dimes plus the number of quarters equals $4? No, that doesn't work, okay? It's got to be D plus Q equals 36, and I've got all of those over here. Now we've got to decide on the value problem, or the value equation. So we know that our dimes are 10 cents, but remember we abbreviate 10 cents as, not abbreviate, but we write it as 0.10, plus quarters is 25 cents, which is 0.25, and that equals the whole thing, which is 420. So let's see, 0.25D, no, that doesn't make sense because dimes are not 25 cents. 0.10D plus 0.25Q equals $4.20. That one looks good, but let's compare it to C. C has got 10 plus 25 equals 420. The only problem with that is that this is not in decimal form. So this one's not going to work because that number is going to give you is way too large, way more than $4.20. So that can't be it. So our answer here is B. All right, 7. Don has a rectangular lot which length is 5 times its width, and the perimeter of the lot is 120 feet. Okay, let's talk about this perimeter here for a second. Let's call this the length and this the width. And yeah, I do my L's like that so you don't think that they're ones. The perimeter is adding up all the way around. So I've got to add up all 4 sides. So my perimeter is going to be L plus W plus L plus W. And if I combine like terms, that's 2L plus, write that as a 2, 2L plus 2W. Now my perimeter is 120, so they actually say 120 is 2L plus 2W, or equals 120. Let's see which one we got there. A, 2L plus 2W equals 120. That one's good. L plus W equals 120. That's actually the bait problem, or the bait answer to see if you would pick it. That one's going to be wrong. 2L plus 2W equals 120. 2L plus 2W equals 120. Okay, so C, A, C, and D are still in the running. Now, has a rectangular lot with a length that is 5 times the width. Okay, so length equals 5W. Now notice that here we're giving you wrong answers that could possibly wrong answers that you might think are right, because here we added them together, which we're looking for 5 times, so that one can't be it. And then notice what's going on with C versus A. Again, they're trying to get you to figure out, is it L equals 5W or W equals 5L? And again, which one's going to be larger? Well, if the length is 5 times the width, the length is the larger one. And besides, it just says 5 times the width, so it's going to be 5 times W. So A is my option there. Now, 8. Lori sold 43 tickets to the one-act play. She has $165 in the envelope. I can't remember how many $3 adults and $5 student tickets she bought. So let's see. We have our number and our values. Here is our number of tickets is 43, and we're using X and Y. So we're going to have just X plus Y equals 43. Let's see where we got that. X plus Y equals 43. And actually, that's the only one that has that. So I know right away my answer's got to be B. But just to double check, let's check the value equation. So we got another total of 165. That one sure enough has 165 there, good. And then we got 3 times adult tickets, so 3X, and 5 times the student tickets, so 5Y. Yep, B checks out. Okay, number 9. The table represents some points on the graph of a linear function. What is the rate of change? This is one of our, similar to a problem we've had way back in the day. Remember, rate of change, whenever I see that, that's the same idea as slope. And when we do slope, that is change in Y divided by change in X. Now, so let me do that in green, just so we have color differences there. So our change in X, I mean, pick any 2 points, it doesn't matter. To go from 0 to 2.5 is 2.5. And then our change in Y, remember f of X is the same thing as Y. So I'm going to pick that exact same spot here. And to go from 4 to negative 2.5, well, that means I'm going down by 6.5. So my fraction over here, my change in Y is negative 6.5. My change in X is 2.5. So I'm going to go ahead and use my calculator to simplify my fraction more easily. If I type in negative 6.5 divided by 2.5, negative 6.5 divided by 2.5. Now, if I press math, enter, enter, it will convert that to a reduced fraction. So it's negative 13 over 5 is my slope. Now, write an equation that's f of x equals, we're looking for basically y equals mx plus b. And I'm using f of x just because it said f of x there instead of y. So I need to get my slope, which is my m value. So I'm going to go ahead and pull that in, negative 13 over 5, plus now my b value. Now remember, we find b at the place where x equals 0. So I see x equals 0, which means that 4 is going to be my y-intercept. So f of x equals negative 13 over 5x plus 4. Okay, number 10. Write the following equations in slope-intercept form. Now remember, slope-intercept is y equals mx plus b. So we're trying to get y by itself. Okay, so I'm trying to isolate this y. Let me go ahead and put my vertical bar down there. Remember, when we have standard form and we're going to slope-intercept, it's always a two-step process. We're going to get the x on the other side. So then those two cancel out here. I'm left with 4y equals, and then negative 3x plus 18. Remember, we can reorder addition as long as the signs go with the coefficients. Now, my second step is to divide everything by the number in front of y, which is going to leave me with y equals negative 3/4 x plus 18 divided by 4 will be 4.5. Okay, the second part of number 10. Again, we want to get y by itself, but this time it's in point slope. Now remember, point slope also is a two-step process, but it's just a slightly different one. The first thing we got to do is distribute that number out. That's actually the slope. So we get y minus 2 is equal to negative 3 times x is negative 3x. Negative 3 times 7 is negative 21. Step 2 will be to move this number with y over to the other side. Now that's going to give me, well, go ahead and write it in here. Y equals negative 3x minus 19. Okay, number 11, what is the slope between those 2 points? Now remember, my slope equation is m equals x2 minus x1 over y2 minus y1. Another way we'd done it in class was we made an xy table, negative 2, 5, and negative 10, negative 16. This one is the straight algebraic approach, where you could label these x1, y1, x2, y2, and plug it in. However, most of us actually prefer doing it from the table. So remember, we're just going to do m is delta y over delta x, change in y over change in x. So my change in y to go from 5 to negative 16, well, that means I'm going to be, well, just do 5 minus negative 16. Actually, I did it the wrong way. You do bottom to top. Negative 16 minus 5 is negative 21, because I just subtract by 21 to get there. Then from negative 2 to negative 8, or from negative 2 to negative 10, I am subtracting 8. Now we're just going to reduce that fraction, negative 21 divided by negative 8, math, enter, enter, is just 21 over 8. Okay. 12 through 15, we're not solving on these, we're just writing what we would prefer to use. Now, whenever I look at number 12, I see x's, y's, and then x's, y's equals constants. That means I'm going to be in either elimination or matrices. I actually prefer matrices of the two, but if you want to do elimination, more power to you. So the reason for that is both are in standard form. Okay, top one, or number 13, top equations in standard form. Bottom equation is y equals, so I got variable equals. That means that I am going to be using substitution. Substitution is because I have one variable is isolated. Number 14, slope intercept on both. Y equals mx plus b, y equals mx plus b. All my numbers are relatively small and nice. That means that is a perfect one for graphing. So I've got slope intercept on both equations. All right, number 1, x's are lined up, y's are lined up equals numbers. That means I am in standard form, and once again, I am in elimination or matrix, and the same thing, both are in standard form. Okay, now on the next sets of these, where there's 2 types for each one, we're going to go ahead and eliminate some of these just to speed things up. I mean, if you want more practice doing these problems, I'm not going to do 17, I'm not going to do 19, I'm not going to do 21 or 23. Or 25, because they're all, 24 is the easier one. I'm just trying to save some time on this review so it doesn't end up being an hour long. Okay, we've already done quite a few of these matrix problems, so it should go pretty fast. Looks like we're set up in standard form, so I've got 1, 1, 43, 3, 5, 165. Now I'm going to go to matrix, over to edit, enter to get past my dimensions, or 2 by 3 if you haven't typed it in yet. 1, 1, 43 straight across the top row, 3, 5, 165 across the bottom row. Quit out. Now I don't have the RREF in there as the last thing, so I have to go back and do it manually. So second matrix over to math, up to RREF, second matrix A, and 1, 0, 0, 1, 25, 18. So my solution is at 25, 18. Okay, use tables to solve. So what I'm going to do is I'm going to go to y equals on my calculator. I'm going to do x plus 4 in y1, negative 3x plus 4 into y2. Once I have those entered in, I'm going to go to the table, which remember is on the graph button. So second graph, second table. And now I can look through here and look for a spot where both y's are equal. And it was nice enough there that these were already set up for me right there at the 0. So I got 4, 4. So I'm going to pick a few x and y values to demonstrate this. So I've got 0, 4, 4. I've got to have that one because that's the solution. I'm also going to choose negative 1 and 1. So that gives me negative 1 and then 3 and then 7. And then also the 1, 5, and 1. So that tells you my answer is 0, 4. Remember, the thing you're looking for is where these two, oh, that's a bad color to use, where these two are equal to each other. Okay, on to number 20. This one says to specifically use elimination. So now remember, on elimination, the way we do it is by adding or subtracting the equations together depending on whether or not they have the same sign or not. So whenever I look at these, I'm on standard form on both, so that's good. Now I've got a negative 2y and a positive 2y. So if I add those two together, then these two are going to end up canceling out, which is what I want. Now x plus 8x is 9x. 8 plus 10 is 18. Now I can divide, not by 2, by 9, and get x equals 2. Okay, that's one of my equations, or one of my answers. Now I'm going to go up and find the other one. Pick one of the equations, it doesn't matter. I'm going to choose this one. So 8x plus 2y equals 10. And then I'm going to substitute in this 2 in there, which is going to give me 16 plus 2y equals 10. I'm now going to subtract off, and get 2y equals negative 6. Divided by 2 gives me y equals negative 3. So my answer is 2, negative 3. Now, we're not going to actually do 21. I just want to make a point about it if you were to solve it. Since these two have the exact same coefficient, positive 1y, positive 1y, in order to make those eliminate, what you would have to do is actually subtract the equation, which means we're going to change the sign of all the different pieces. And then now when I add them together, these would cancel out. I'd be left with negative 3x equals negative 24, which is something I could solve. Okay. 22, U substitution. I see that I've got y equals here. So on the bottom equation, I am going to write negative 2x minus 3. Where the y is, I'm going to open up my parentheses, equals negative 7. And I'm going to substitute in for y. So that's 6x minus 11. Now, we're going to distribute this, but make sure you're distributing the entire negative 3. So I've got negative 2x. Negative 3 times 6 is minus 18x. Negative 3 times negative 11 is positive 33 equals negative 7. Now let's combine our like terms. That will make negative 2 times, or minus 18 is negative 20x plus 33 equals negative 7. Let's subtract off 33 on both sides. Negative 20x equals negative 40. And now I'm running out of room here. I'm going to divide by negative 20. And that's going to give me, I'm coming over on the side here, x equals 2. Now I'm going to jump up to the top. I'm going to pull this equation out. Y equals 6x minus 11. And again, I'm going to pull this number and put it in there. So that would be 2. Simplifying down, I get y equals 12 minus 11. So y equals 1. So my answer to this problem is 2, 1. And put that there so I can see it easily. Okay. Moving on to number 24. Now, I chose 24 as the one to do specifically because there's a little bit more work. It's not directly in y slope intercept form. Now, honestly, this is probably a better candidate for a graphing problem. I'm sorry, not a graphing problem, a substitution problem. But we're going to do this one by graphing just to show you how to do it. So I've got negative 2x plus y equals negative 2. Now, what we're going to do here, we need to isolate the 2y. So I'm going to add the 2x, to do that in red. I'm going to add the 2x to both sides. So that gives me y equals 2x minus 2. Which means that for this one, my slope is 2 over 1, and my y-intercept is negative 2. So I'm going to go down to negative 2, and then I'm going to do my rise and run of 2 over 1. So rise 2, run 1, rise 2, run 1, rise 2, run 1. Okay, I'm going to go ahead and pull up my straight edge so that I can get an accurate line here. Now, for my second one, here my slope is 2 over 1, but my y-intercept is, well, there's nothing written there, which is the same as plus 0. So that is equals, my b equals 0. So here we've got this, rise 2, run 1, rise 2, run 1, rise 2, run 1. So since these two have the exact same slope of 2 over 1 on both, but different y-intercepts, they're never going to touch. There is no intersection point, so this is a no solution. Remember, on these, what you're looking for is the place where they cross. The place where they cross is the answer. Okay, moving on to number 26. We want to find the value of x if x negative 8 is a solution. We did one or two of these back on one of our example problems towards the beginning of the unit. Basically, what we're saying here is that y equals negative 8. So I can substitute the negative 8 back into this equation. 6x plus 2y equals negative 4. So here I'm going to substitute this guy in there and plug in -8. And now just simplify and solve. So that's going to give me 6x minus 16 equals -4. We're then going to add 16 to both sides. And I'm out of room here, so I'm going to jump over to the side. That gives me 6x equals -4 plus 16 is 12. Then divide by 6 gives me x equals 2. So if y is -8, then x equals 2. So essentially that point would be to -8. Okay, 27, exact same idea, except we're using 3y. And so we're going to be plugging in for the y. So whenever I go through and do this, I'm going to get 6x. Oh man, I just realized. Nope. I did it right. Okay. We're plugging in 3 for x. So that's 6x plus 2y equals -4. We're going to plug in the 3 here. So then 6 times 3 is 18 plus 2y equals -4. We're going to subtract the 18 on both sides. And that gives me 2y is equal to -22. Divide through by 2, and y equals -11. So again, 3, -11 would be that point. All right, 28 is asked in kind of a weird way. What value of x makes that equation true? All it's asking you to do is solve, and there's not much room to do it here, so I'm actually going to copy it off on the side. -5 times 3x plus 5 plus 8x equals 10 minus 2 times x plus 10. Okay, first I'm going to go ahead and distribute on both sides. -5 times 3x is -15x. -5 times 5 is -25 plus 8x equals, the 10 drops down, -2 times x is -2x, -2 times 10 is -20. On that one, make sure that you're distributing the negative along with the 2. All right, now we're going to combine like terms. Over here on the left, I've got the 15x and the 8x, which is going to combine to be -7x minus 25. Over here on the right, I've got the 10 and the -20. That'll be -2x minus 10. Now I need to collect all my variables on one side and numbers on the other. So I'm going to add 2x to both sides, causing those to cancel out. That leaves me with -5x minus 25 equals -10. Now I need to get all my constants on the right side, so I'm going to add 25 to both sides, which gives me -5x equals -10 plus 25 is 15. And now we're going to divide by -5, gives me x equals -3. There's a lot of work in there, but we got x equals -3 as our answer. Number 29. Find the value of f of -3. Now remember, all that we're doing is replacing every single x with a -3. So f of -3 equals 3x squared minus 7x plus 3. So plug in our -3 for both of those. Okay, that's where we replaced all of our x's. And then the beauty of that is we can go to the calculator and type it in just like it is. 3 times -3 squared minus 7 times -3 plus 3. So that equals 51. Okay, number 30. is that a solution? Now remember, when we're testing is it a solution, we got to plug it into both equations and see if it makes it true. So I'm going to do that for the first equation, 5x plus 2y equals 12. Now we're going to plug in a 5 for the x and a -1 for the y. And then that gives me 25 minus 2 equals 12, which gives me 23 equals 12. That is not true, so it is not a solution. It would have to work in both. If it had worked in there, I would check it in this one, but since it doesn't work in that one, I'm going to stop and just move on. Okay, 31. Which ordered pair is a solution to this equation? Now, one thing you could do is you could start plugging in and seeing which ones would work, or you could solve. Either one works. Something that I want to do, though, is just to keep it easy, I'm going to plug into this one because that seems like a pretty easy equation to plug into. Y equals 3 times x. Well, if I do 3 times 1, that is 3. So that y is not 3 times x, so it can't be A. All right, let's go over here and check this one. Y equals 3 times x, so 3 times 2 equals 6, which is not the one. That one can't be it either. Okay, now let's try it over here. Y equals, 3 times x, 3 times 6.5. 3 times 6.5 gives me 19.5. Yep, that checks out. Okay, now let's try it over here. 3 times 19.5. Well, I definitely know it's not going to be 6.5, so that one can't be it either. So I could just plug in on these things. Now, just to double check, I'm going to go ahead and try it out. I'm going to plug in 2 times x plus 2y. So 2 times 6.5 plus 2 times 19.5, sure enough, is 52. So B is my answer. It's one of the reasons I love multiple choice. You don't have to do a lot of difficult work. You can just check things and validate the answers. Okay, 32 and 33 are very similar to those last types of problems we did on the elimination assignment. What would I multiply the second equation by? Now remember, all I'm trying to do is force one of the variables in the bottom equation to have the same value as the coefficient in the top equation. So here I've got 1 and 4, and here I've got 4 and 8. There's actually 2 ways I could do this. I could multiply the entire bottom equation by 2. If I did that, I would get 2x plus 8y equals 126. And then I've got the negative 8y and the positive 8y. So 2 actually works. The other way that I could do this would be to multiply the entire equation by 4. That would give me 4x plus 16y equals, and then 63 times 4 is 252. And in that particular case, then I'd have the 4x and the 4x. I could do elimination by subtracting. So my answer is 2 or 4. And on the test, give me one or the other. I would take either one. Okay, number 33, very similar to the one before it. I want to multiply the first equation this time. Again, I could multiply by 2 because then that 2 times 2 would give me 4. Or I can multiply by 8 because then the 8 times 1 would give me 8. So 2 or 8. All right, so that's it. I apologize for this review being 45 minutes long. Feel free to reach out. I'll be available every single morning on Google Meet from 8 to 8:35 to 8:40. Code, as always, is EVHS Mr. Love. And test is going to be early next week.